we must solve together. Okay, next. In order to overcome this problem, we are chemical engineering student from Semarang State University, consisting of me, Saka Kusuma Nurjati, Muhammad Lutfi Amiluddin, and Muhammad Adam Purnawan. We provide an innovation entitled, next, yes, green synthesis of T-drag-based PGQD-GH composites as photocatalyst material for enhanced hydrogen gas production through water splitting method.
Cogen is an innovative composite of phosphor-graphene quantum dots substituted with graphene hydrogel utilizing the abundant biomass waste from tree decks as a material for hydrogen gas production. Next. This rating method carried out on this idea is using a systematic literature review, which is based on internationally reputable journal articles.
Cogen was synthesized from T-dregs with trivinyl phosphine as the doping source via hydrothermal method at 240 degrees Celsius for 12 hours. As a result, bright yellow colored phosphor-doped graphene quantum dot was obtained. Furthermore, for the PGQD-GH composite, the synthesized PGQD solution and graphene oxide were prepared using hydrothermal method for 12 hours at 180 degrees Celsius.
Okay, the Cogen works by utilizing the help of sunlight, which will help oxidize the sacrifice agent, sodium sulfate, into sulfate ion, which will increase the efficiency of the hydrogen gas production reaction. PGQD will facilitate the transfer of electrons from the valency band to the conduction band, so that it will be ready to break down water molecules into hydrogen and oxygen in graphene hydrogel.
The XPX spectra results show the successful incorporation of phosphor atoms into the graphene quantum dot structure. PGQDs containing PC3 bonds predominantly cause electron redistribution and polarization to occur effectively, thus enhancing the photocatalytic activity of Cogen.
Okay, this is the TEM image of Cogen. The TEM image of Cogen shows PGQDs adhered and uniformly dispersed on the graphene nanosheets, indicating the successful incorporation of PGQDs on the porous graphene hydrogen surface. The observed characteristic indicates that the highly porous structure of Cogen facilitates effective mass transport between electrolytes, gas, and substances, thereby enhancing the photocatalytic performance.
The Cogen also had a very high hydrogen production rate of 20.47 millimole per gram hour, indicating the excellent photocatalytic hydrogen production activity of Cogen in the water splitting process. The hydrogen production rate also increased along with the highest concentration of 200 milligram per liter and could maintain the high hydrogen production rate continuously with 1,000 hours of operation.
The hydrogen production rate of Cogen composites has also been compared with the hydrogen production rate of other composites based on various references from existing reputable journal articles, where it is shown that Cogen has a remarkable production rate of 20.47 millimole per gram hours. Based on the explanation that we have presented, we can summarize it into 3 points, which are: first, Cogen is an innovative PGQD-GH composite for enhanced hydrogen gas production synthesized from T-Drag's biomass waste by water splitting method. Second, Cogen has excellent photocatalytic stability by maintaining a high H2 production rate of 20.47 millimole per gram hours. Third, this innovation can be a solution to fossil fuel dependence by increasing hydrogen production through the water splitting method in supporting clean energy transition in Indonesia. This innovation can also provide more value for ZHG waste that has not been optimally utilized. We hope that the innovation we have presented can address the challenge of low carbon development and the transition to clean energy using renewable sources with the potential for realization. Thank you for your attention, and we warmly welcome any feedback and suggestions for our innovation.
Thank you very much for the interesting presentation about photocatalyst for hydrogen. So yeah, Indonesia also has potential for generating green hydrogen, especially from its geothermal potential. So the topic is very nice, very interesting. And actually there is one and two questions from the Slido. How likely is it that this technology can be scaled up, and what are the possible challenges? Hello?
Okay,
Yeah,
thank you very much for the really good question. Let me answer it. This method has only been tested on a laboratory scale, and maybe a larger scale testing is required to fully understand its effectiveness in hydrogen production. However, we have already obtained remarkable test results that can serve as references for larger scale trials.
Yeah. And what do you think if there is any possible challenges ahead? If it is to be scaled up or pilot scale, what need to be overcome or prevent?
Okay, so we need preparation before we can scale up to industrial or mass production. So we need more research before we can
Yeah.
apply in a real world. So maybe there is some challenge. We the economic aspects of this innovation have not been explicitly mentioned, but however, even we are utilizing solar energy, which is abundant and renewable, along with the availability of GDREX biomass waste as raw material, we believe that this innovation remains realistic for implementation. Furthermore, the hydrogen that produced from this process high energy content, approximately 2.5 to 3 times greater than the slide, making it highly efficient as fuel.
Okay, I want to add my friend a quick answer. So this innovation is also an idea that we took from various reference to internationally reputable journal articles. So in writing this work, we also use the systematic literature review method, but by looking at the effectiveness results shown and the use of natural materials that are abundant and environmentally friendly. So this is a great potential that can be developed on a large scale. Thank you.
Okay, thank you very much. It is nice to hear that it have the potential to be scaled up to a large scale. Yeah, once again, thank you very much for the presentation and also answering the question. And now we move to the next speaker. Please welcome Irfan Zaki Irawan and Meta Padmanaba, who will be speaking to us on the using remote sensing based random forest algorithm to retrieve carbon stock value of uncultivated area. So the time is yours. Oh, enggak. Okay, sorry. So apparently she has not sending any presentation, so we move to the next speaker. Novia Nur Rahmawati, Adip Fakhrudin Yusuf, Eko Agus Suyono, Budi Sediati Daryono, who will be speaking to us on colchicine-mediated polyploidization, a potential way to enhance the carbon capture capacity of Euglena sp. Please, the time is yours.
All right, thank you so much. Could you next slide? Okay, good morning for all attendants. We know that greenhouse gases have been increasing primarily due to rising level of carbon dioxide. Next. In 2021, the International Energy Agency, or IEA, reported a concerning trend that global carbon dioxide emissions have been rising annually. The main contributor to this emission are electrical and heat production sector. Next. The electrical and heat production sector account for 43% of the total. Next. And this followed by the transport sector at 23% and the industrial sector at 19%. Next. Since the start of the Industrial Revolution, carbon dioxide emissions have skyrocketed. Back in 1960, emissions were 9.39 billion metric tons, and by 2022, they had jumped to 37.15 billion metric tons. This dramatic increase shows just how crucial it is to take urgent action on climate change. Next. To reduce carbon dioxide emission, we need to develop effective carbon capture system. There are several practical methods being explored, such as using forests and crops for carbon capture and ocean fertilization with iron. However, each of these methods has its limitation. They often require large area, take a long time to show results, can be expensive, and might impact biodiversity both on land and in the ocean. Next. Microalgae, as photosynthetic organisms, can capture carbon dioxide. Next. They have remarkable ability to turn carbon dioxide into various valuable bioproducts. Next. Microalgae can grow much faster than plants and can capture carbon dioxide 10 to 15 times more efficiently. Plus, they are highly adaptable and resilient, thriving even in extreme conditions where the other plant might struggle. Next. Aegona gracilis, a type of microalgae, offers several advantages for carbon capture. This photosynthetic organism can sequester carbon dioxide at an impressive rate up to 1.4% per day and 500% per year. Additionally, Aegona gracilis uses this carbon capture to produce paramylon, a compound that serves as both an energy and carbon storage mechanism. Remarkably, paramylon also has potential health benefits including anti-tumor properties and anti-inflammatory effect. So, how do our research findings differ from previous studies on carbon capture using Aegona gracilis? Next. Our research focused on a new approach that we've developed a mutant strain of Aegona gracilis through a process called polyploidization. Polyploidization involves increasing the number of chromosome sets in the organism using a mutagenic agent known as colchicine. So, how does polyploidization help with carbon absorption? By increasing the number of chromosomes, we make the cell larger, including parts like in the grana in the chloroplast. This helps the algae photosynthesize faster and absorb more carbon dioxide. Next. Given these challenges, we are excited to present our research on colchicine-mediated polyploidization, a potential way to enhance carbon capture of Aegona gracilis. Next. We collected samples from Dieng peatland in Wonosobo, Central Java, Indonesia, taking 3 separated samples to ensure accuracy. Next. Once we had the sample, we isolate and purify the Aegona gracilis cell to separate them from other microorganisms. Next, we place the single culture into microplates and treat them with colchicine at 5 different concentrations for 24, 48, and 72 hours. After treatment, we subculture and evaluate them based on survival rate, cell size, DNA concentration, growth pattern, biomass, and growth kinetics. Let's now explore the preliminary result of our study. We concentrate on three key factors. The first one is survival rate. This shows how well the cell endure under different conditions. Our results indicate that higher colchicine concentration and longer incubation time significantly affect the survival rate of Aegona gracilis. Additionally, polymerization induced by colchicine treatment has shown promising results. It can lead to increase in genome at 0.1%, 1%, and 0.5% and 5% at 48 hours and 72 hours. Also, the increase in the cell size. And based on our observation, we identified 6 optimal candidates. Next. The chosen sample then cultivated and subjected to further assays for more in-depth analysis. Next. Our results show that Aegona gracilis treated with 0.1% and 1% treatment achieved the highest dry weight and the greatest biomass productivity. This outcome correlated strongly with the increased cell area observed in this treatment. The larger cell area contribute to accelerate dry biomass and enhance biomass productivity. It is also important to note that the cell biomass influenced not only by cell area but also by photosynthetic the cell cycle. This factor together play a crucial role to determining overall biomass. Okay, moving on to growth parameter, we observe this treatment has positive result with the peak occurring day 10. However, our analysis of the specific growth rate revealed a decrease in the rate of cell population per day for 0.1% and 1% colchicine treatment. This results in a longer doubling time, indicating that this treatment required more time for mitosis to complete. This observation aligned with findings studies by Minso and Nishat-Mansouri that suggests polyploidy can inhibit microtubule formation during mitosis, leading to extended mitotic times. Next. And the last result about growth kinetic models is to understand the life stages of Aegona gracilis. Additionally, this model helps us to determine the optimal culture system for enhancing the capability of Aegona gracilis as a carbon capture agent. Our results demonstrate that the Gompert and logistic growth model are particularly effective in describing the growth kinetic of Aegona gracilis. This is supported by R-square value reaching up to 0.9, indicating a high level of fit for these models. So, based from our analysis, we can conclude that treated Aegona gracilis reveal a higher dry weight, biomass productivity, cell density, specific growth rate, and doubling time compared to the wild-type cells. The enhancement of these parameters suggests a potential correlation between polyploid Aegona and its effectiveness as a carbon capture agent. So, for our next project, we will take a comprehensive studies on the factor that regulated carbon capture capacity, such as transcriptome analysis, carbon capture efficiency, and cultivation system. Thank you for all your attention. I look forward to any question you may have and to discussing these exciting possibilities further. Aegona polyploids enhancing the local potential to ensure our future life.
Yay, thank you very much, Novia Nur, for your interesting presentation. Yeah, the idea is very interesting, like minimizing the carbon footprint using algae to capture carbon. And there are actually some questions here. First of all, do you know if this idea has been implemented in other countries? Maybe you can directly answer the question if you want.
Okay, for Aegona gracilis is the first time
Sure.
to adaptable for carbon capture.
Mhm.
So I think it's a pioneering result to next advantage or making Aegona more advantage for carbon capture.
Is there any countries that using this algae practically to capture the carbon? Do you know if?
Okay, I know it, but
Uh-huh.
for Aegona gracilis is acceptable or
Okay.
implement.
Okay.
several, but for polyploid, they're never doing that. They're not yet doing it.
Okay. Thank you for the answer. And yeah, there is also another question, like since it deals with the living things, the algae, and there is what are the parameters that to be considered to enable the environment of the algae keeping they alive?
For the environment, right?
Exactly, yeah.
Yeah, it's Aglana have 3.5 pH for their life cycle until 7
Mm-hmm.
pH. And also they can use medium called Kremsmeyer for their nutrient to enhance their life cycle.
Mm-hmm. Okay. And with all the enable environment that you stated earlier, what do you think or your other team member think that how possible is it to be implement this at the large scale?
Okay, for implementing the Agona grass list for in a large scale, we need to collaboration with industrial because it also need a huge amount of nutrient also, and also we need to optimize their cultivation first before we implement it to more larger scale.
Yeah. Thank you very much for the answer. And I think there is no more other questions. So once again, thank you for the presentation and for answering the question. Now we move to the next speaker, which is Abdul Hakim Aziz, who will be speaking about cost-effective and energy-efficient inverter of grid solar power plant, PEQ cell 7 level inverter with fuzzy logic controller to regulate output voltage. So please, the screen and time is yours.
Check. I'm audible and visible.
Yes.
Okay. So I'm starting my presentation in 3, 2, 1. So good afternoon from Indonesia. My name is Abdul Hakim Aziz. I'm representing my team research under the title of cost-effective and energy-efficient inverter called PEQ-Cell 7-level inverter, which is for off-grid solar power plant application. So basically, we are doing a research in order to boost the efficiency of the converter from the PV system to the grid, which is more cost-effective and also energy efficient. I'm working with my friends Rafi Damas and my professor in PENS named Novi Ayu Pindarko. So thanks for the opportunity. So yeah, this is our work. So what drives our work is three things. First is the climate problem due to the existing coal power plant that emit the carbon dioxide. Everyone knows about this. So we want to look for the energy alternative, and that is PV system, right? But the problem with the PV system, you need this inverter in order to convert the DC electricity, which only applicable for your handphone, for example, or maybe for some other electronic devices, but you cannot inject it to the grid. In Indonesia, we have this network called PLN, our national grid. You cannot inject it directly. That's why you need that inverter, a tool called inverter that convert DC to AC electricity. But the problem with the current inverter is that the second one, it's quite expensive. The PV itself is already very expensive, even though in the several years, if we look back, there is a significant reduce, but we need to push down the green premium from it in order to make sure that the energy produced from the PV system is more affordable, and inverter is responsible for almost like 60% of the cost invest for the solar power plant. That's why we focus in order to optimize the price and also the energy efficient from the inverter itself. The third problem is that there is in solar PV system, we know this something called energy intermittency, right? So it's very dependent upon the situation of the environment. Like if you look at the right hand picture, it shows the irradiance the PV received, which is quite you know, unreliable, and the energy produced from the PV will follow the down and the rise up of the irradiance in itself. So we need to make sure that even if the irradiance it receives go down, the energy produced still can be optimized. That's how this research work. We want to look for the most efficient inverter and also make sure that the energy produced is quite reliable even though the irradiance received is quite low. So what is Fuse in it actually? So basically, it is a tool in order to convert DC to AC, and then yeah, this is the whole research. The left hand picture, the below one. So it is a prototype, and yes, it is tested on the library on the lab, and what makes it different is that on how it produces a higher value of electricity and the quality. I will show you in the next slide the 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 waveform that is produced by this inverter. The I will show you also the total investment, how many electronic devices you should invest, you should establish in order to make one with the inverter. And the right hand picture is the what's it called, this the signal in this yeah, in order to drive the IGBT. So there is an electronic devices, it's very technical, but instead of this POC there is electronic device called IGBT, and you need these three pair of signal in order to drive those electronic IGBT. So this is the result of the POC. So the electricity are going to obtain from the POC is going to be much more smoother. So if you look into the grid of the electrical network, any electrical network is not going to be pure sinusoidal, and that means that it's going to you know, dissipate more heat into your electronic device. For example, if you charge your it's quite getting harder time by time. It means that whether the electricity or your electronic device is not that efficient. So the purpose of this fuse is make that waveform become more smooth, so that your electronic devices is not that damaged by the electricity where you plug in your handphone, for example. So the left hand picture is the result of the PUC, and the comparison is that the other one, the right one. This is the conventional model, and it's quite not smooth as a electricity signal, and we do not want that in our grid. So what we invest, so basically there are the left hand picture is the 7 type of the inverter currently developed, and the last one is PUC. If you look at the price book inside of this inverter, PUC is the lowest one. It's and the highest one is the FLC, which is called for flying capacitor thing, and it's for the prototype scale, it's only below the 200 USD odds. Yeah, or in under 3 billion rupiahs if you convert it into IDR. And yeah, you can see the number of the components. You only need 3 type: IGBT, capacitor, and also diode. But the PUC only need 2 in total, 6 IGBT and also 1 capacitor, which means that you can reduce the cost in order to establish one inverter. Okay, this is only one inverter, but imagine in 1 megawatt solar power plant, you probably need 6, for example, which is maybe is going to take you higher number of money to buy those inverter. And how it deals with intermittency. So this is the proof. If you look at the graphic in the left one, the orange shows there is the orange shows that this PV is not controlled by what's called as FLC, which is fuzzy logic controller. This fuzzy logic controller, if you put it on the PV, then even if the sunlight is gotten by the PV is lower, then the reduction of the energy produced by the PV is not going to be that significant. If you can see the percentage here, is the biggest one is only 5.1%, and the orange one without any controller it's reduced until 15.2%, which is very significant. It's only one PV, but imagine if you have 1000 PV, for example, for your solar power plant. So if you control your PV with this what so-called as a fuzzy logic controller and inject it inside of your inverter, then you are going to have not only more efficient, but not only more cheaper inverter, but also more efficient inverter. So yeah, that's all my presentation.
Okay. Thank you very much, Abdul Hakim Aziz, for the presentation. Yeah, it is indeed very interesting. With as you know, that solar also one of the renewable energy that massively planning in Indonesia right now. So we received some questions regarding your presentation. So first of all, as we know that inverter is a mature technology, how is the current or existing inverter technology that are available in the market?
Okay, so I'm working in EPC right now, which is engineering, procurement, and construction company, which is basically a contractor for solar power plant. So the main, if I can mention one brand which is very competitive from China, H Huawei, thing, and they are the common one, but their technology is quite solid, but we need further. The total distortion, or the distortion is the disturbance of the electricity produced, is good. They have a very good quality of electricity, but the cost is very high. That is why the researcher is like competitively looking for the most efficient and also cost-effective inverter, which is not only good, but in order to invest in one solar power plant, you need to make sure that the green premium or the investment you put in it is quite low, so that the renewable energy can be installed in a much more number, right? So the existing brand is good, but not quite good in terms of price.
Thank you very much for the answer. And may I know the comparison between the existing, the rough estimation from the existing inverter that currently available in market, and also with the FLC that you have mentioned, because you have mentioned that the PLC is cheaper than the one that available in market.
It's not actually FLC. FLC is like the, what is it? FLC is not the tools. It's kind of a coding you put inside of the inverter in order to make sure that even if the sunlight the PV receive is lower than the PV, the inverter can still produce higher amount of sunlight. So that is FLC. But if you ask me, what is the comparison between the the efficiency between the PUC and the
PUC,
existing brand? Is that your question?
Yes, PUC. Yeah, true.
Maybe in terms of price, I have shown you this kind of graph. That's the price is the lowest one compared to the novel research, existing research. But the other one, for in terms of efficiency, I can show you with this picture. So the left one is produced by PUC. This is the electricity you can put in the grid. Is even if there is still like a ladder, it's not that smooth. you still need filter. So filter is what makes it more smooth, but the size of the filter you put in it is going to be smaller compared to the right one. The right one is another type of the inverter which is commonly used, which is PWM. So PWM is the driver of the signal in order to make the IGBT or the switch uh, on and off at the same time. I've shown you before. This is the PWM, the right one. So the conventional one use that kind of PWM and produce the right picture, which is not that effective. It produces this THD, total harmonic distortion, which is the disturbance for the electricity, which is at the rate of 30%. Meanwhile, the QC only in 90%. So if you put a filter for both the inverter, the one is going to require you smaller filter is the QC because it's already smoother compared to the conventional one.
Okay. Okay, thank you very much for such a extensive answer. And actually, there is one more question. With all the benefits you have mentioned earlier, what are the obstacles for PUC MLI with FLC to be ready for the market?
Okay, so yeah, this is my final project in campus, and I have graduated actually, and this is not commercially put in the market yet. I think that in order to, in any type of renewable energy, green technology, you need to make sure that even if your product is price competitive in price, but you need to make sure that you have this kind of branding, what's so called as a branding thing. You need to make sure that you have the name in order to compete in the market. And I think that this is what the university in all over Indonesia, I think, do not have. We do not have the accessibility in order to enter the existing market, which is already being solid, especially for the kind of technology. So I think the drawback is going to be how to make sure that this kind of technology having the bargaining power inside of the market. So there's the capacity for the student how to not only mastering the engineering side of tools, but also how to understand the market. But second of all, I think that this is only prototype, right? Means that if I directly insert the electricity produced to the grid, then maybe the grid will directly off, or my tools will just blow up because the capacity is only for like 60 watt. 60 watt. So I think that the drawbacks is in the terms of how to boost the watt, the watt, the energy it produces is quite small, so smaller, still smaller compared to what the grid required.
Yeah, thank you very much for the presentation and also for answering the questions. Very nice, Lee. And let's move to the next speaker, which
Thank you.
thank you very much once again. And the next speaker is Salma Sultana and Sana Fatina. Which will be speaking about a case study of Komodo water harnessing low carbon technology for sustainable development in Indonesia. So please, the floor is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning from Germany. Thank you for being here today. My name is Salma Sultana, and I have the honor of representing my team. And my co-writer, Shana Fatina, is virtually joining from Labuan Bajo, Indonesia. So on this occasion, I will present our work about Komodo water. So Komodo water is working to address water challenges in Indonesia using sustainable technology. It is a low carbon technology, and we will explore how these solutions will contribute to the sustainability in Indonesia, especially in the areas facing water scarcity. Next. So these are the outlines. I would like to introduce the overview of low carbon development in Indonesia, and then the impact of the Komodo water, what they do to the environment and their impact to the communities. And we will discuss the success factors of the implementation of Komodo water, and also the recommendations for the policymakers. Next. So these are the current situation of Indonesia. As we know that Indonesia is one of the countries that are most affected by the climate change. On the right, you can see that there is an activist holding a banner, and they protest with the impact of the climate change because the tidal flooding hits the area of Muara Angke in Jakarta. It is actually my hometown. And in another part of the city is the other extreme. So in Cirebon, West Java, there is a long drought. And these images just show how serious the situation in Indonesia. And because of this, Indonesia has taken some important steps in order to overcome the impact of the climate change. So in the National Medium Term Development Plan, or RPJMN, it is included that Indonesia has strong commitment to protecting the environment. So we have a plan for 2050 to build a low carbon and climate resilient future with the goal of reaching net zero emissions by 2060 or sooner. So this journey towards low carbon development is very important in Indonesia, so that we are able to address the climate risks and also protect our planet in the future. All right, so although Indonesia has already put the policies, unfortunately there are some barriers in the low carbon development. There are 4 main barriers. The first one is economic barriers. So we noticed that traditional industries often find it easier to get financing because there are fewer investors interested in the renewable energy. And also, starting renewable energy technology is very expensive, so it would be very hard to get things off the ground. And for the socio-cultural barriers, there are some of the cultures that may potentially create conflicts in the implementation, and also there is a lack of skills and experienced workers in the field. Meanwhile, for the technology, one big issue in Indonesia is lack of local enterprise expertise. So there are the technologies in the low carbon projects are imported, so it makes it very inefficient and become costly. Meanwhile, for the governance barriers, the complex licensing and coordination process, it's hinder the development of low carbon development in Indonesia. Next. So these are our research objectives and methods. We would like to explore how well Komodo waters are being implemented in the area, in the remote area. And also we want to assess the impact of the technologies to the local communities. And also we are looking to understand what makes this technology successful in the local communities so that we can replicate in other areas of Indonesia. So we, to gather the information, we interviewed the small-scale fishermen and also ice distributors, which are the residents, local residents, and the data collection and analysis is supported by the surveyors from Water and Energy for Food. And we focus on 4 main areas. In here, we have income and livelihood, innovation usage, food impact, and also water and energy impact. So, as the background, Komodo Water, since 2012, they provide an affordable clean water to people living in remote areas using sustainable technology. So the reason why Komodo water established is because there is a paradox that we know that Komodo National Park is a very famous tourism spot in Indonesia. Unfortunately, the local residents, the people in the fisherman village, they have difficulties in accessing clean water. So these are the tough conditions that are experienced by the local residents. They have poor water quality and scarcity of clean water sources, which leads to their health and overall. Many people are not aware of how to maintain good health practices, and also there is a high level of diarrhea, stunting, and also child mortality. And also, they have an expensive water prices, and it becomes a burden for them to gain clean water. And also, since it is a remote area, there is a limited electricity, so that it is affected their refrigeration to make their catch, the fishes, to be able to last long is affected, and it leads to a lot of food waste because they cannot process the fish in the refrigerator. And another one is the widespread use of single-use plastic packaging. So it is one of the most crucial issues. The plastic pollution have polluted the sea. And next, so the Labuan Bajo has a very crucial issue in the waste management because the waste issues is making people's lives worse. And also the lack of ice supply of supporting fisheries leads to 35% of fish and seafood being wasted. So it is a lot of issues here. And also the increasing number of tourists in the area could lead to the increased demand for water and also the increased amount of waste. Next. So these are the business model of Komodo Water. They provide an end-to-end services, starting from the survey. They provide the access to clean water, drinking water, and also ice blocks for the fishermen. So next, these are the two main products of Komodo Water. So clean water and drinking water, and also the ice blocks. So these products are designed to be both effective and environmentally friendly. As you can see, the clean water and drinking water are powered using sunlight. And also it helps the communities to get the resources they need while protecting our planet. So it is a win-win solution. Next. So we believe from the interview with the fishermen, we noticed that the solutions is really innovative and effective because it doesn't need electricity, so it is more reliable technologies to be implemented in the remote area, and also cost savings. It is very important for the communities, and also there are community benefits. The reseller of the water is among local residents, and they got additional income from that. And also there is the fishermen are able to have to sell a fish with higher prices because they are able to make the catch last longer than before. So yeah, it's not only provides low carbon technology, but also supports local economy and improve the quality of life in remote areas. Next, this is the impact of the Komodo water. So it is a very significant impact. More than 14,000 people have positively impact through the distribution of the gallons of clean drinking water and also ice blocks. So these achievements just show how Komodo water makes a real difference in both environmental and also community well-being. So these are the success factors. The first one is understanding the needs of local communities. Komodo Water noticed that the local communities has an urgent need to access of clean water and also ice blocks. And the second is selecting suitable low carbon technology because it is located in a place where electricity is limited and there are a lot of sunlight, so the solar powered technology is used. And also empowering communities to take ownership of the technology and its benefits. It's a very crucial point because when we empower people in order to manage the technology, it would become long-term and more sustainable. And also, Indonesia is it's a collective society. We have a spirit of gotong royong, so it is a very important point that we can learn from Komodo water. Next. So the conclusion is the low carbon technologies can effectively address the issues while also contributing to the broader sustainability goals. And next, the recommendation is that we need to prioritize the community-driven solutions because it is in our nature to support the effort of collectivity. And also, we need to facilitate access to funding and support so that more companies in the low carbon technology can thrive, and encourage data-driven decision making, and also strengthen the policy and regulatory frameworks from the government side. Next. Thank you.
Thank you very much, Mbak Salma, for presenting. This is very very nice and interesting initiative. I really hope this initiative could be replicated and also adopted in other cities in remote area, small islands in Indonesia, because it's kind of ironic when you said there is lots of problems happening in Labuan Bajo, like water and then also waste management and also the fishermen that could not get enough ice for their fish. And yeah, it's kind of ironic because Labuan Bajo is very touristic, touristic spot for destination in Indonesia and also very beautiful island. And I actually have one question, how to make, you've stated earlier that there is some of the technology for providing the water, reverse osmosis and so on, and then also for providing the fishermen ice cubes, and then how to make this technology sustain, because some of them there is technology placed in small island and then the local people empowered to maintain the technology, but then at some point there must be a maintenance, and then maybe there is some of the problems that the local people doesn't have the knowledge about it. So how to make all this technology sustain for a long time for the local people there?
Thank you so much for your question. It's very interesting. So it's about the sustainability of the technology, since we noticed that there is a need from local communities to access to clean water. So I think from the demand side, it is ongoing. So we can make sure that the production of the produce of the technology can last. And also about the implementation of the technology, so I also convey that the local people are empowered to operate the technology. So from Komodo Water, we give the trainings to the local people. So one of the challenge is language. So all the standard operating procedures are using Bahasa Indonesia in order for them to understand, and also we have training from the overview of the technology to the technical details, so that they are not afraid, because some of them think that the technology is so advanced, they are afraid to use it because they are afraid to be broken. But we make sure that it is okay for you to use the technology. These are the instructions. If you have any difficulties, then we can assist you, so that we hope that they can operate it independently, and they are also have the skills for troubleshooting. So I think that's my answer.
Thank you very much. Yeah, I think so. Empowering local people and then giving them technical skill is one of the significant how to overcome the problems technology sustainability. Yeah. And there is also another question here. Yeah. What about the capital and also operational maintenance costs? Is it like Komodo Water searching for the sponsor, or there is also another source of money for implementing this kind of technology?
Thank you for the question. So for the funding, Komodo Water has their own funding. So it's a bootstrapping from the founders. And also Komodo Water actively seek grant to the NGOs and also other institutions that support the development of LCTs.
Okay, thank you very much. Maybe one last question. Is there any plan future for Komodo Water to replicate this kind of technology needed in other areas in Indonesia?
So I think this is also one of my closing statement that I want to share. So yes, Komodo Water is open for collaboration, especially for academics in the water sectors who want to work together to solve the scarcity water issues in Indonesia. And also, I think since there is a success in the Nusa Tenggara areas, it can be implemented in other areas, and Komodo Water will plan to expand the impact and also the technologies in other areas of Indonesia.
Okay, thank you very much, Ms. Salma, and give applause, please, everyone, to her here. It's very interesting. Hopefully, it can be replicated in all of Indonesia, especially in the area that is have water scarcity and waste management problem. And for the next speaker, please welcome Nabila Aryuni, which will be speaking to us on CarbBlock, Carbon Location App, web-based geospatial low carbon emission monitoring application utilizing big spatial data. So please, Nabila, the time is yours.
Oke, masuk ya. Okay, good morning everyone. Assalamualaikum warahmatullahi wabarakatuh. Thank you for the opportunity. We are honored to be invited to this presentation. Before we begin, we would like to express our deepest gratitude to the moderators who have facilitated today's session and make sure everything went smoothly. And we are sorry when we come to slightly above.
Sorry. Yeah, we couldn't see your presentation here.
Okay,
Could you please try again? Yeah, now we could see.
Flashnya kelihatan. Okay.
Take some time.
Okay.
Okay, now we can see your slides.
Ini aja.
Can you please maximize the presentation slides?
Okay, wait.
Yeah. Okay. Okay. Yeah. Now we can see your slides. Please kindly start. Okay, now, yeah, you can start. You can see the slides already.
Okay, sorry, we have any problem here.
No worries.
First, let me introduce my team. First, we have Nabila Aryuni, who is an expert in GIS with she extensive experience, and she will get us through the discussion and result section. Next, I would like to introduce Samudra, who is a specialist in GIS, and he has played a significant role in the analysis of vegetation and peatlands through satellite imagery and data processing, and he will focus on the methodology section. Lastly, I am Sakif, who is in charge of GIS and media. I will give an explanation of the background research. Together, we would like to have a discussion here. We are confident that our collective effort will have an impact in the future. Okay. We will start with background. We know that Indonesia is a tropical country with biodiversity, and 51.2% of its land area is tropical rainforest. In addition, 13.5 million hectares are peatlands, which are currently experiencing many challenges that need to be faced, both land conversion and forest fires. Of course, this is the cause of the large amount of carbon released into the air and reduced carbon absorption. Therefore, efforts are needed to overcome this problem by creating a vegetation distribution map as an initial step in overcome it. Here is our methodology that will be presented by Samudra Irfan.
Okay, Sakif, thank you for your letting me. I think here I will explain related to the methodology that we use. Methodology for the carbon location. This research will use cloud computing-based approach for the processing large spatial data obtained from modest satellite images. The methodology used in this research consists of several main steps. First step is left image. We have data collection. In the data collection, there are two steps that we need to do. The first is satellite image data. The left data, we have a satellite image data. Gross primary production or GPP and net primary production on NPP data will be collected from the MODI satellite. This data were chosen because they provide an accurate estimate of vegetation productivity, which can then be used to calculate carbon stock. On the right, we have additional data. Additional data such as land use map, land cover, and climate data will be collected to improve the accuracy of the analysis. This data will be accessed through various open data sources as the Geospatial Information Agency. In Indonesia, we call BIG, and WordCamp. And additional information, the data we use follow the methodology of external data taken by the responsibility party. Next, please. In the next step, we need to do data processing. Data processing, we have two steps. The first is a data pre-processing. The collected data will be processed for the noise removal, humidity correction, and the atmospheric correction. This step is important to ensure that the data used the analyzed of high quality. And the second one is the carbon stock calculation. The carbon stock calculation using a formula that relates GPP and NPP to carbon stock in vegetation. This calculation is done specially by dividing Indonesia into small grids to get a more detailed estimate. And the data can be produced with the unit value in the million tons of carbon per year. In the next step, we need to do geospatial application development. Next, please. Geospatial application development, we have three steps. The first is a cloud computing platform. Geospatial application will be developed using cloud computing platform in the form of web-based geospatial application to process large spatial data efficiently and in the real-time. And the second one is a data visualization. The application will display the result of the carbon stock calculation in the form of thematic maps that can be accessed interactively by user. User can view the distribution of the carbon stock within the current time span and explore the data based on the region of interest. And the third, we have a recommended nature-based solution. Based on the carbon stock calculation result, the application will be provide personalized action recommendation for the each region, such as the development of the urban park, rooftop garden, vertical garden, and peatland restoration. And the next step, we need to doing validation and testing. Next, please. The validation and the testing. The first, we can do a validation of the calculation result. The carbon stock calculation result will be validated using field data and previous result to ensure the accuracy of the developed model. And the second one is the application testing. The developed geospatial application will be tested by policymaker in several regions and user testing to evaluate ease of use, functionality, and the effectiveness in the supporting decision making. And the last step, we need doing data analysis and interpretation. Next, please. Data analysis and the interpretation. The first we can do spatial data temporal analysis. The process data will be analyzed to identify spatial and temporal trend in carbon emission and the carbon securities across Indonesia. And the last is the interpretation of result. The result of the analysis will be interpreted to provide in the deep insight to areas that require intervention and the most effective strategies to reduce carbon emission. Thank you. Next will be continued by my friend to Nabila. You are welcome.
Okay, so now I will present about the results of our research. And so there is a chart territorial carbon in Indonesia, and we can see that there is a significant increase in this number of carbons in Indonesia. So this is certainly makes carbon one of the important problems that must be resolved immediately. And then next. So in our research, there is 3 map results, and the first map is map of distribution of peatlands in Indonesia, and it can be seen from the maps that the distribution of peatlands is quite rare, especially in the Java area. However, this can be maximized if the available land is developed and maintained properly. And then the second map is land use map, and the map shows the land use in the Sleman area of Yogyakarta. This map is then used as an analysis of which locations are still free and can be utilized for the creation of parks and other green vegetation development. And then the last maps is infiltration maps. The map shows the level of soil infiltration for its area in Sleman, Yogyakarta. This map is then used to analyze which area have high infiltration rates, where this infiltration affects the fertility of the soil in planting trees and making parks for carbon reduction. This map is then used to analyze which areas have high infiltration rates. So from our research, we got the summary that carbon is effective tool as a first step in reducing carbon emissions in the world as a map designed to analyze potential location for carbon storage. Carblock help identify areas best suited to absorb and store carbon from the atmosphere. By utilizing this technology, countries and companies can develop more targeted climate change mitigation strategies, optimize land use, and contribute significantly to global effort to lower greenhouse gas concentration in the atmosphere. Carbon, therefore, has an important role to play in supporting sustainable initiatives and helping the world towards a greener, low-carbon future. So thank you for your attention, and I will end this presentation.
Thank you very much for Carblock team for your presentation. So we received also several questions here. I think the initiative and the idea of Carblock is also very interesting, and I think it's beneficial as well for local governments or other governments agency. How actually to maintain and or manage the application in order to keep the data is up to date? That's the question.
Okay. The first, the data is not open source for like. So in Indonesia, wait, I will. Okay, so in Indonesia, there is several data leaks and resulted in data that was difficult to access. But in government, wait, I will discuss for a minute.
Yeah, sure.
Okay, additional information data can be accessed every year and can be obtained from the right certificate and can be updated every year. And the data is usually get from web. Like Indonesian, there is a BIG, Badan Informasi Geospasial. So in BIG, in web geoportal, the government, what the meaning of, wait. The government provide the data and updating by year, every year. So we can get the data from that web. But for now, the data is not open source for any people. So just the government have the access to use that data like that.
Okay. So to maintain this Carblock application, the government, the Badan Geospasial will regularly update the data once a year, yeah? And
Yeah, sure, like that.
yeah. And one more question. So yeah, from the data result that you have analyzed, so you said that there will be a nature-based solution that you might offer. So what are the NBS initiative that you offer based on the data result that you've got?
Sorry, can you say the
Okay.
question again?
Yeah. So during your presentation, you show the picture of your analyze about the carbon storage in several locations across Indonesia, right? And also, you said that in the carbon block, there you will provide the nature-based solution based on the data that you have analyzed before. So, what kind of nature-based solution that you and your team would like to offer in the app? Maybe like, for example, maybe kind of wetlands or anything. Is there any carbon nature-based solution that you would like to offer regarding the carbon storage data that you've already analyzed?
Okay, wait a second.
Sure.
Okay, based on the carbon stock calculation results, the app will provide personalized action recommendation for each region, such as the development of urban parks, rooftop gardens, vertical gardens, and peatland restoration. Like that.
Okay. Okay, then thank you very much for answering the question. And once again, thank you for Carblock team for presenting your idea. And now let's move to the next speaker, which is Dinar Kurniawan and Muhammad Galang Merdeka, who will be speaking to us on dual solution for increasing oil recovery and reducing carbon emission, CO2 enhanced oil recovery. So please, the time and screen is yours. Sorry, I think, yeah, Mas Galang is not here. And then let's move to another presenters, which is Zulfikar Adlan Natsir, who will be speaking about geodesy for sea level rise monitoring as a bridge to low carbon development in coastal area. Okay. Maybe let's move to the next speaker because Zulfikar also not yet here. The next speaker is Hazel Julius, who will speaking to us about uncertainty quantification of an acoustical meteorological model. So please, Hazel Julius, the time and floor is yours.
Okay, thank you very much, Ms. Chair. So do I get my slide already here? Okay, so shall I start now or? Yes. Okay, so good morning, everyone. Thank you very much for being here in the conversation. So my name is Hazel. I know my title is long enough, Uncertainty Quantification of a Lagrangian Acoustical Meteorological Coupled Simulation, but don't worry, we will go through that in a while. So how should I, next slide? Okay, so this is actually the outline of my slides. I will explain to you about the problem itself, the acoustic noise problem in wind energy. So this is the connection with the low carbon development. And afterwards, I will introduce you to the method itself. I will introduce you to the Lagrangian outdoor simulation, uncertainty quantification, and also the global sensitivity analysis itself. And then I will, of course, explain the implementation, results, and discussion to conclude. And of course, I will give you the outlook. So how should I? Okay, you guys do it. Okay. So now I will introduce you first to the acoustic noise problem in wind energy. For those of you who live nearby a wind turbine, probably, you will probably understand this problem. So the problem of acoustic in a wind turbine is not as loud as you live nearby airports or even some loud constructions place, but the problem is that it's always there. So you can always hear the noise from the wind turbine. So here we have done the research about how far it goes, but there's actually a problem, and you can see it on the next slide. Yes, so for the outdoor noise, it actually depends on the meteorology. So as you can see here on the right side, it's basically the usual condition. So you have warmer ground and then it's colder on the atmosphere. So you can see the sound actually reflect above the atmosphere. So you cannot hear the noise because it's absorbed by the air. However, if you have some condition like on the left side of the screen, you see the ground is cold, and you can see in this picture that the noise actually propagates to you. So you will have this problem. So, and next slide, for this case, I will just go through 3 simple parameters: wind speed and wind direction, temperature profile, and humidity. If we can get this data correctly, we can predict the noise of the wind turbine. However, this data is uncertain. If you go outside, you can check whether the wind speed and direction is always the same or not. I assume it's always not. And, no, not yet. And yeah, therefore it's a problem. Then if we have an uncertain input, how then we get the certain output? So the next slide, actually, I will mention a little bit about how do we actually simulate outdoor sound propagation. First, we just solve partial differential equation, and then we can also do ray tracing. We simulating sound propagation by tracing the path of the sound rays. And the last one, actually the simplest one, is we use probabilistic or geostatistic method. So this is the easiest one, but right now I will just mention this method, which is called Lagrangian sound particle model. So we actually release a lot of particles and we treat that as a sound wave. So next. Yeah, this is actually the basic example here. So you have the X, basically the sound particles location, and it moves through the wind. So you simulate your particle through the moving medium. And I will not go through deep with the equation here because we don't have time, but if you want, you can ask me afterwards. And in the next slide, actually, you can see that this model can calculate the phase angle. So you basically simulate the interference, and it can do any kind of boundary condition. So since it models physics accurately, so of course it depends on temperature, humidity, velocity, frequencies, and so on. So this is basically how we model sound. And then how do we deal with the uncertainty of the input then? So next. So this is what we call uncertainty quantification. So we have uncertain inputs, we have mathematical models, and we have uncertain outputs. So usually what we do is we just select a lot of distribution function, and then we run through that to our model, and then we analyze the output. However, as you see, for example, this Monte Carlo method, you therefore needs to run your code multiple times. So for example, you have 10,000 of samples, you need to run your code 10,000 times. For example, in my case, I have for each samples, I need 10 hours of computer simulation for a low resolution simulation. Therefore, I need to 10,000 times 10 hours. So 100,000 hours, which is not possible. So I therefore have another idea to do that, mainly called surrogate model. So instead of running the model 10,000 times, we just create another models and we analyze that model instead. And the models that I'm going through here is called the generalized polynomial chaos expansion, but this is not the most known one. the most known one basically just using interpolation or machine learning models, but here we are using generalized polynomial chaos expansion. Basically, you model your surrogate, code by using these polynomials. So f is my code, and I kind of represent my code with this certain polynomials, which is orthogonal. And why does it need to be orthogonal? Because therefore I can use quadrature here, and I can get the constant. So don't worry, I will not go deep here, but if you want to ask, feel free. Next. Yeah, so with that polynomial, we can also get the statistical properties like this, variance and expected value. Therefore, we can analyze our output then. And yeah. However, this has a problem. But before I talk about the problem, I will also tell you that this method can be used also for sensitivity analysis. So with the statistical properties, we can check which parameter is the most has the most influence in our model. So here, we can do that. However, it is not easy mathematically, and yeah, it's not really easy to achieve as well, but we have those parameters. So here's the example. We have the data of the meteorological condition in one areas, and we use Monte Carlo here. So we use 10,000 samples, but for this one, we are having low resolution simulation. So how does it look? We have it like this. It looks approximately the same here, but you can see we have different expected value at the valley. But maybe the next slide will be better. Yeah. So this one, you can see that I get the speed of wind, and also the topography of some places is the most influential parameter. So I do it again without the topography because we cannot change topography, and the result is, and I have this setup. The source of the sound, the wind turbine is located on the top of the hill. So this is actually located in the real hill in Portugal, but the result is like this. So, nice color. So you can see here, if we have a normal wind speed there, you can get like 4 dBs different every day. And so that you know, 1 dB increase in sound, basically you have you feels like 2 more stores around you. So if you have 1 car, and then you double the number of cars, you add 1 dBs. So you can see how uncertain the noise are. And yeah, this is actually just using the different kind of boundary, but it does not really matter here. Next. Yeah, so all methods that I'm using shows the same result, that speed of wind basically is the most influential parameters here. So I want to try simulating with only wind. So how does it work if we have every parameter the same, but only the speed of wind changing? And how does it look? It looks like this. Oh no, it's like the distribution of the wind. And this is actually how it looks. So you have the same result with 4 dBs with wind only. You have 4 dBs deviation on the valley. And this is using Monte Carlo. And how about the method that I just told you? You can see that the orange line is using polynomial chaos expansion, and the blue one is using Monte Carlo, but the polynomial chaos expansion is only using 20 samples, meanwhile the Monte Carlo using 8,000 samples. So you can see we reduced the number of samples by 8,000, but it still looks the same because, yeah, you can see there. We also try the same for 3-dimensional, and still it looks similar. So what's the difference here is actually the standard deviation, but yeah, the pattern still looks the same. So if you want to know why there are differences, you can ask me. So yeah, because I don't have time. Yeah, so the conclusion is that the generalized polynomial chaos expansion can be used to model uncertainty with super cheap number of samples. And by that, we also prove that only the wind speed variation does affect the uncertainty of the sound propagation, especially on wind turbine. So that's all my presentation now. I return this back to the chair. Thank you.
thank you very much, Hazel Julius, for your excellent presentation. Uh, yeah, it's actually the topic is very new for me, but it's very interesting to see all of the simulation, what kind of the the method being used, and there is actually several questions here. First of all, is you have stated that there is a there is two different methods, right? Like the Monte Carlo and the polynomial. And then why the sample between two of different method is very significantly different? And maybe related to the first question, like is 20 samples? I think there is another one is 20 samples, right? Is it enough and quite representative? Thank you.
So yeah, thank you very much for the question. This is very interesting. So can we go back after this? Yes, more. Let me just do it myself. Yeah, I think this one. Yeah, so you can see here, so my study here is basically to prove that this method works because we are using some weird meteorological condition and also weird topography case. So how does this GPC works? Basically, by simulation, we are just creating a mathematical models. So it is written in some code because we are basically just doing partial differential equation solving using the code. But the way this GPC works is that we, is it okay? Okay. Yeah, so the way it works is basically we deconstruct the mathematical models. So we remove parts that is not needed because I think you already have it on the previous slide that by removing the non-usable parameters, we can reduce also the complexity. So that's why we have less samples, and yeah, this is the power. Like it feels like a magic because 20 samples compared to 8,000, and massive magic. So.
Okay, I think I can still use this, right?
Oh, okay.
Yeah. Okay. Yeah. So the answer is it's quite similar with the pattern, yeah. Yes. Sorry. Okay. And then another question is, I think you've also stated in the presentation like the height of the source of the sun, the sound, right? And then when you get those data, and then what is actually used in the real life? I mean, what is the solution if you get those sources of data, and then what do we have to do with that data?
Okay, thank you very much for the question. This is very, very important. So usually if you want to, I mean, at least in Germany, when they want to build a wind turbine, they need to ask people around whether they want to do it or not. And yeah, this is the part of the study, whether the wind turbine will disturb their sleep or not, will disturb the condition of the animals nearby or not. Because if it is yes, therefore they cannot build it there. So yeah, that's why we need this data. Like we need to know how much noise that wind turbine produces. Because if it is too loud for the environment, they cannot build it. And they have low threshold in Germany compared to other country. Because yeah, as you guys know, if you are living here in Germany, how sensitive we are to the noise.
Yeah, okay. So it's basically for the decision for the project developer or something to place the wind turbine as well. Okay. Wow, such a nice, interesting presentation. And any other question from the audience here?
Who wants to ask questions?
Yeah, please.
Okay, so thank you for your explanations. I just wondered, like, is this kind of research, especially the effect of the winds, right? Is it applicable to the wind conditions, especially in Indonesia, and the construction of technology, whatever it is in Indonesia, especially? Thank you.
Yes, that's true. But I want to show you back to my previous slide. So can you get back to those table there? The table? So basically the table that you will see here is the distribution of the wind that we got from our measurement in Portugal. So this is Portugal topography. So if you want to do it as well for Indonesia, what we need to do is basically we need to measure all of those things, like the speed of sound, temperature, particle gradient, and so on. And after that, we can do the same simulation of analysis. So yeah, that's kind of tricky, but the method still stands everywhere you want to do it. Thank you.
Thank you very much for answering all of the questions. So Julius, once again, give applause for Julius for a remarkable presentation. And let's move to the next speaker, which is Dinar Kurniawan, who will be speaking to us about exploring CO2 geological storage potential in the South Sumatra Basin, a comprehensive assessment. So for Dinar Kurniawan, you can start your presentation.
Okay.
Okay.
Thank you
Cool.
for the
Yeah.
time. Okay. Okay. Wait. Sorry. Okay. 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 This is my presentation about dual solution for increasing oil recovery and reducing carbon emissions, CO2, enhance oil recovery. Okay. Wait. Okay. Sorry.
Yeah, your slide. We can see your slide from here. You can start the
Okay.
presentation, yeah.
Okay.
Mhm.
Okay. Okay. The outline of this presentation is sorry. The outline of this presentation is begin with introduction and then methods and then result and discussion and then conclusion and then reference. Okay, the first is introduction. Okay, this is the global carbon cycle. This is CO2 emission from the factories and then going to the sky and then used by plants and then going deeper and then it will be going to the sediment. The in the right we can see the carbon sequestration. There are many methods. But the first we can see this you can inject the carbon dioxide in coal mines or deep rivers or in the liquid oil or gas reservoir. Okay, but the biggest problem is you have to reduce the carbon dioxide in the surface. Okay. This is the sediment map in in Indonesia. Yeah. And this is the research area. Yeah. This is the South Sumatra Basin. This is relatively big than other basin. Okay. Okay. In this basin, you can see this. This is there are many oil fields. There are 127 with total original oil in place through sorry 7,277. If we do the EOR, yeah, we can inject carbon dioxide 243 million tons. This is not a small amount, yeah. Okay. And then the methods. Okay. The first conceptual reservoir model was created using CMG based on rock and fluid properties from one field from South Sumatra Basin. And then reservoir model is Cartesian grid model with invert 5-spot pattern with one injector well and 4 producer well. Grid model is a compositional model consists of CO2, M2, and hydrocarbon component from C1 to C11 with rock properties, permeability 200 millidarcy, porosity 25%, and then rock is saturated with oil and water, and then initial oil saturation is 0.7, and then reservoir pattern volume is 4,000 acre-feet, and then reservoir pressure and temperature is this. Okay. Okay, the relative permeability curve in this illustration is oil water, and then in the right is gas liquid, and then all wells are perforated into skins. The first is through perforation skin, and then and the second is just perforation skin. Okay, the well constraint is injection rate 1 mmscfg with oil production rate 100 stock tank barrel per day. Okay, today's cases are determined from running a simulation of the well's perforation scheme. Simulation is conducted for 40 years, and then amount of oil production and CO2 stored are compared, and the data scheme is chosen for optimization of injection and production rate. Optimization is conducted by varying the well constraint. Injection rate varying from 0.5 until 10 mmscfg, and then oil production rate 250 until 2000 and this. Okay, and then the result and discussion. Okay, from the base case, you can see that a just perforation scheme has higher oil production and better oil splitting due to gravity drainage. Amount of CO2 stored is higher in a just perforation scheme, as the ejected CO2 is filling the upper layer first, and then full perforation scheme has higher oil rate at later years, as the remaining oil in the reservoir are still able to flow and be produced. Okay, full perforation scheme has faster CO2 injection breakthrough, and then reservoir pressure develops faster in full perforation scheme because the breakthrough of injection gas helps achieving steady state condition faster. And then in both cases, reservoir pressure declines below CO2 critical pressure. Hence, CO2 miscibility does not occur. Okay, this is the optimization scenario. sensitivity analysis was conducted by varying CO2 injection rate and oil production rate, and then 200 simulation cases were created to determine the optimum amount of oil production and CO2 stored. And then unrealistic results were filtered out of the analysis. Okay. Oh, sorry. Okay, this is the reference. Okay. Thank you.
Thank you very much for the presentation, Dinar Kurniawan. Yeah, we do have several questions regarding your presentation. The first question is, are there any negative impacts on the carbon dioxide injection into the reservoir?
Okay. There are no negative impacts because there only a positive impact because it can reduce the CO2 in the surface. Yeah, because CO2 in the surface injected to the oil reservoir.
Mm-hmm.
Okay.
Okay. Thank you very much. And as far as I know, the CO2 injection is quite economically extensive, like it's very high cost. And that's why I would like to ask, like, under what condition or circumstances is this CO2 injection is technically and also economically feasible to be implemented in maybe specifically in South Sumatra Basin?
I'm sorry. My focus is only on the technical topics.
Okay. Yeah, no worries. Maybe one more question, like you inject the CO2 to the reservoir light, and then where did you get the CO2 actually? Is that from direct air capture or where is the CO2 coming from?
Okay. In the South Sumatra Basin, there are many factory that that emits CO2, and then there are many gas fields that contains CO2. So there are two examples that we can get the CO2 to inject in the South Sumatra Basin.
Okay.
Like that, maybe.
Mm-hmm. Do you want to add something? Okay. Yeah. Is there any maximum from the injection to the source of the CO2? Is there any maximum distance in the technical perspective?
Okay, there are no maximum distance because CO2, if there the if the distance is too far, we can transport it using ships, something like that.
Okay. Okay, thank you very much, Dinar Kurniawan, for the presentation and also answering the question. Give applause also again, everyone. Yeah, once again, thank you. And we will go to the next speaker, which will be again Dinar Kurniawan. I think you submitted two abstract, isn't it? Dinar Kurniawan. The first one that you just present earlier is dual solution for increasing oil recovery. And then the second one is exploring the carbon dioxide geological storage potential in the South Sumatra Basin.
Okay.
Uh-huh.
Okay. 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 Okay.
Mhm.
Wait. Okay.
Yes. Yeah,
Okay.
we can see your presentation, so the time is yours.
Okay. Thank you. This is my second presentation about exploring sorry about exploring carbon dioxide geological storage potential in the South Sumatra Basin, a comprehensive assessment. Okay. Okay. Uh, this is the illustration of main geological storage. And the first is we can store carbon dioxide in the depleted oil or gas reservoir. Or second, we can use CO2 in enhanced oil recovery that uh, uh, we discussed it in the previous presentation. And then the third is deep unused saline water, and then deep unminable coal seam, and then use of CO2 in enhanced coal bed methane recovery, and then other suggested option. Mhm. Okay, so there are many methods for storing CO2 in geological formation. Okay, this is the map again, and then this is the South Sumatra Basin. Okay, and then um, sorry, actually, I don't know why there are many slides that not showed in this presentation. Yeah? The methods. Yeah, the first, we assess the ge- ge- uh, geological aspect. From geological aspect, uh, injected CO2 in the field will be the CO2 will be dissolved in the oil and then lowering its viscosity and then causing it to swell, as well as providing pressure drive to move the oil to the production well. By combining CO2 EOR with storage could result in an average additional oil production of approximately 12% of OIP, original oil in place, if the CO2 completely miscible with oil. Okay, this is the most attractive option for transitioning to geological storage of CO2, since approximately of 40% of the CO2 ejected remains behind in the reservoir after it has displaced the oil. So we can see in this illustration, this is the stratigraphic column of South Sumatra Basin. This is many formation like Palembang and many more. So in this stratigraphic column, uh, we can see that the main hydrocarbon threat was caused by uh, anticline, anticline from northwest to southeast and became the first threat to export. So the best geological reason why petroleum reservoir became the best CO2 storage is its trapping mechanism. Okay, this is the geological reason. Okay, and then the next reason is Indonesia CO2 emission CO2 emission target in 2030 is reduced 29% than 110. Okay, and then Sumatra Island has oil reserve approximately 4.6 billion barrels of oil. It means that 61.8% of the total Indonesia reserve. Okay, this is Sumatra Island. Then Indonesia, especially South Sumatra, became top three candidate source that received the highest score for capture suitability and first rank in CO2 storage in oil and gas field. You can see in this table, Indonesia, especially South Sumatra, there are many CO2 sources like natural gas processing and then critical coal power plant and then like fertilizer plant. Okay, and then in the right you can see estimate CO2 storage capacity in oil and gas field. You can see in South Sumatra, yes, only South Sumatra, there are 44 fields, oil and gas fields that can store CO2 nearly 800. This is only in South Sumatra. Okay, but in the Philippines, it is in one country, it is just under 400. Okay, and then in Thailand there are 100, but it is in one country like Vietnam. Okay, okay, and then okay, and then the field is located close to CO2 source. Okay, in South Sumatra Basin, there are many CO2 sources. The first is Nati Alpha Field, and then many more. Yeah. This is the location. There are gas plant, yeah. In Batam, the CO2 maybe transported to in South Sumatra Basin, in South Sumatra, sorry. Okay, and then this is the gas field. The pipe gas field located nearly South Sumatra Basin. The first is Muara Enim, Palembang, yeah. And then Provinuli, and many more. Okay, with very CO2 concentration. Okay, and the next reason is CO2 source in South Sumatra and Jambi were accumulated into formation such as Batu Raja Formation and Talangakar Formation. Okay, some of wells were drilled in this formation. Due to high CO2 concentration, more than 70%, those wells were abandoned. For example, such as well Suku 1, Pyung 1, Pyung 2 has CO2 contains 70%, sorry, 87%, and then 70%, and then 70% respectively. Furthermore, those wells are potential asset as a CO2 source in, in the near future in order to apply CO2 EOR. And then close distance between CO2 source and oil field are changed for that method. Okay, thank you.
Thank you very much, Dinar Kurniawan, for presenting 2 times in a row. It's very interesting presentation indeed. And let's go to the question and answer session. Is there any one who would like to? Okay, cool. There are 2 questions from here. Mas Dinar, please.
Okay.
Sorry. Hello, can you hear me now? Or?
Okay, yes.
Oh yeah, thank you very much for the interesting presentation. I'm Hessel, I'm from DLR. My question is actually regarding to your CO2 sources afterwards. So you have told us that adding CO2 underground will increase its permeability, but also does it change the soil characteristic of the matter itself? Does it change the porosity? Does it also change the tortuosity and any kind of those parameter? Or it's still the same? So yeah, that's basically the question. Thank you.
Okay.
Thank you very much, Hassel. Yeah. Dinar Kurniawan would like to answer.
Okay.
Mhm.
Okay. By injecting CO2 into the reservoir, especially in oil reservoir, it only changes the oil viscosity, not the rocks porosity and permeability. It only changes the viscosity of the oil. It will be lowering the viscosity, so the oil will be easier to move and then to produce in the surface like that.
Okay, thank you very much for the response. And one more questions from here.
Hello, Mas Kurniawan. I just wondered, like, from your presentation, you explained that Indonesia is, especially in the South Sumatra, is like top 3 carbon dioxide storage, and in oil and gas and etc. So I would just need your view. Like, do you have any kind of suggestions? For example, like if there is kind of company or people would like to excavate those oil or gases in that areas, and so it will, affect the carbon dioxide to be exploded to the atmosphere. So, what kind of like response or responsibility from the company or people who want to excavate that? Thank you.
Thank you, Mas Biju.
Okay. Actually, maybe okay. Actually, there are many oil company in the South Sumatra Basin, and then I have no idea about their vision about CO2 storage in the South Sumatra Basin. Okay. Thank you like that.
Okay, thank you very much for the response and for presenting again 2 times in a row. Once again, thank you, Mas Dinar Kurniawan. And then we can move to the last speaker, which is Zulfikar Adlan Natsir, who will be presenting about geodesy for sea level rise monitoring as a bridge to low carbon development in coastal area. So please, Zulfikar, the time is yours.
Yeah, thank you, but yes, I am the last. I don't really know. I think the schedule should say that I'm not the last, but yeah, here it is. Let me share my screen, but I cannot do it while the other people are sharing. Okay. Yeah, but first of all, it's nice to meet you again, but yes, after some time, I think you hope you still remembers me.
Yeah, Mas Zul. It's very nice to meet you too. Long time ago.
So good day, everyone. My name is Zulfikar Adlan Adzir. As was already introduced, I'm a PhD student in the Institute for Geodesy and Geoinformation in the University of Bonn. And I will talk to you today about what is the role actually from geodesy, especially on the sea level rise monitoring to not invent, but to develop some strategies in terms of low carbon development, especially in our beloved country, Indonesia. But let's start with, the climate change, the looming climate change. What is climate change? I don't really want to talk about the detail of climate change. You can talk me and argue with me about that on the question and answer session. But what I wanted to say to you is the climate change has been intensified in the last 100 years. Yeah, actually it was intensified starting from the Industrial Revolution back in the 8th, 19th century. The value was 1.1 degree of Celsius, mean global surface temperature. It was increasing through the last century. It sounds small, but it is big. And just FYI, the Paris 2050 agreement that almost all of the country in the world has signed tried to limit the pollution, or so to say the emission of the greenhouse gases, so that the increase would not exceed 2 degrees Celsius by 2050. But that's just FYI. And one of the proxy or the essential climate variables one say to the climate change is called global sea level, and has been found to rise by 20 centimeters over the last century, the last 20th century. And it was accelerating further in the last 2 decades by, I think, 7 or 8 more centimeters in the last 20 years. And the rise was amplified, or so to say exemplified, by the land subsidence on the coast. And these made the coastal cities, islands, and archipelago like Indonesia are uniquely at risk. And it was more becoming at risk because we're located in the global south. Why? Because we are developing economies, meaning that we don't really have any, or not any, but a lot of means, not only to quantify the rate of subsidence and also the sea level rise in our country, but also then how to mitigate or how to, so to say, lower the risk of the sea level rise. What I wanted to show you is one of the picture here at the below of my presentation. It shows the mosque close to Tanjung Priok, I believe, that was pictured by the NY Times reporter back in, I think, 2017, showing how big the problem in Indonesia, especially Jakarta, is. And there are a lot of news article about it. One of them was in the Jakarta Post on the right side of my slide. Indonesia giant capital city is sinking. Can the government plan save it? I will try to answer that in my research, but then let's go to the next slide. Sorry. The big question, I think, especially on the technical side, is how to connect the sea level rise and land subsidence. Granted, because sea level rise is rising, essentially, and land subsidence is sinking. So if we live in the coastal area, If the sea is rising and the land is subsiding, then we will get a double effect, not only from the sea level rise and also on the land subsidence itself. But how do we connect it? Can we connect it nonetheless? It turns out that geodetic data network could be utilized or used to bridge between these two parameters. And in essence, answering how big the sea level will rise on my city especially. However, due to the lack study connecting them, especially in our beloved country of Indonesia, many are not aware. But I hope anyone who listened to my presentation, whether it is on site or online, are aware of the problems. And this study tried to act as a starting point to further investigation on the topic. I'm not saying that I will be the one who changed the world in terms of this topic, but I wanted to start to have some discussion and also some debate about this. And in this case, we will use three geodetic data network, namely relative SLR from the tide gauges, sea level rise from the altimetry, and also vertical land motion from the GNSS station or GPS station. I will not get into details again, the time is limited, but if you wanted to ask me, please do so on the question and answer session. I will skip the definition of geodesy. And these are the data that I use for the study. So I used a combination of 49 co-located tide gauge station cores and altimetry throughout Indonesia, and I do several peer-reviewed pre-processing processes that was meant to, so to say, ensure the quality of the data itself. Again, I will not get into details, but if somebody wanted to ask, please do so later in the session. And the result shows, I will show some results directly. The first one, it turns out that from the 22 sites on the information, from the data itself with the median time span of 9 years, it shows that the median of vertical land motion and also the sea level rise from the altimetry agrees with global mean, meaning that Indonesia has a median rate of sea level rise by 3.5 millimeter per year, and it agrees with the global mean. However, if we see specifically in some location, in northern Javanese coast as well as in southern Sumatra, it sinks 2 times faster than the other location in Indonesia as shown in the map above. However, there is a peculiar thing that the tip of northern Sumatra, as you can see here in Sabang on the, again, northern Sumatra, is uplifting instead of sinking. Why? It turns out that when we do a further check in Sumatra Island, there is 2 big trends that was happened on the western part and on the eastern part. The western part, which mainly lies on the subsidence, mainly lies on the tectonic plates. On the meeting of the tectonic plates tend to uplift, whereas on the eastern part of Sumatra, which was, the soil is, not was, mainly constituted of peatlands, and it is subsiding. The result for this one is only preliminary. There is a further investigation needed to be done. But let's go then not only on the results but also on the forecast. If we do the forecast in 2050 and 2100, there will be 6 locations throughout Indonesia, namely Jakarta, Surabaya, Air Bangis in Sumatra, Gunung Sitoli also in Sumatra, Benoa and Cilegon, who will rise by 50 centimeters. Of course, the sea level plus the vertical land motion. And one example, the big example, is in Jakarta, in Tanjung Priok, I believe. It is estimated that the sea will rise relatively by 66.3 centimeters by 2100. It is gloomy, but when we see the reference, or if we see the previous study, it was better than before. 10 years ago, the rate of subsidence in Jakarta was more than 1 centimeters per year. And now what I have found, it was 6 millimeters per year. It's still big, not 6, sorry, 8. It's still quite big compared to the others, but the rate of subsidence has slowed during the last 10 years. There are several take-home messages, but I do not really wanted to go through all of this because of the time limitation. But what I wanted to say to you is that indeed Indonesia is sinking by the value that corresponds to the global mean, but special consideration needs to be put upon mainly northern Javanese coast and also on the western part of Sumatra, and on several outlying islands as well, small islands like Gunung Sitole and Ayubangis, which is essentially a small island. The results of this study is still on review, but if anybody wanted to look for further update, you can follow me on X or Twitter or Instagram with the handle at Zulfikar Adlan. But let's go back. I wanted to add one more slide on the relation to the technological innovation of the LCD that I was just explained to. How do we, so to say, develop the LCD strategies? There are several strategies. I will not really get further into details again, but what I wanted to mention are several alternatives. The first one is preserve peatlands and wetlands, which what needs to be done on the eastern Sumatra, and also to implement and enforce zoning in terms of city planning, and also integrate the sea level rise and disaster risk again into the city planning. And it is really evident and needs to be done as well on the northern Javanese coast. Otherwise, there will be a lot of Indonesian who needs to move, especially on Pekalongan, Semarang, Jepara, and also along the northern Javanese coast. But lastly, what I also wanted to say is that not only that we need to do a technological innovation in terms of not only quantifying the value, but also how to mitigate the risk, but we need to empower local communities and also please to apply local wisdom. In this sense, some people say it in Bahasa Indonesia as kearifan lokal, but I do think that there is more than just a folklore, and also there is more than just just a saying. So there was several strategies of the there was several alternative on how to develop corresponding LCD strategies out of the result of my study, and I hope that we can do some thorough discussion and start to think about not only us, but also our descendants for our beloved archipelago. That's it. Thank you. I hope that you have any comment. If anybody wanted to ask, please feel free to email me at nadzir@uni-pon.de. Terima kasih.
Thank you very much, Mazul, for presenting your research. I think it is also important to know and to forecast the sea level rise in Indonesia so that we can create a mitigation action plan in relation with the sea level rise. So do you have any question here? Okay, here there are actually 3 questions. So the first question coming from Hazel, please.
Hello. Thank you very much for the opportunity. Nice to meet you, Mr. Adlan. I'm Hazel. So can you go back to your slide number 7?
Yes.
Yes. So this is actually a beginner question. So I can see here there is different sea level rising. Depends on your location. So can you please explain to us like what's the physics behind that, and why do we have different, like a lot different, even though it's still on the one continent or one island, and also why do we have decreasing sea level there? And yeah, thank you very much.
Thank you, thank you. That is actually a really good question. I do not really want to go into much details, but imagine that every city is like a person, Mas Hessel. Do you think that every person is unique? I hope that you think so, right? Then every
Yes.
city and its surroundings, it's also unique. The main physical things or physical aspects that could contribute to these differences, the first one would be what is the soil constituency on the location. There are several locations that built upon karst, that built upon alluvial sand, that built upon peatlands, and it behaves differently when, sorry, not when, but when the times went on. That's the first part, the main part actually. The second part would be when we talk about the coast, we need to also talk about the bathymetry or the topography of the bottom of the ocean. It plays also quite a big role on how the water or how the ocean behave and rises. And lastly, it is still a big debate, I think, but again, throughout the world, as I mentioned on earlier slides, that regional effect on the sea level and its rise is still a really wide open question, and it is still investigated even this minute. So I hope that I can answer your
Yes,
question,
very clear.
but,
Thank you very much.
Yeah, you're welcome.
Thank you very much, Hazel. And then the second question, Mas Pinju.
Okay, such a really impressive research, Mas. Yeah, I'm Piju Sagala. Actually, I still work with the C4 aircraft, and we also did the same kind of research in the northern coast of Java. But actually, we installed like the road surface elevation table to get to know the implications of the impact of sea level rise in the northern coast of Java. So I have two questions actually.
Yeah.
As you already explained that you use like course data from BIG, if I'm not mistaken, like is it open sources? I mean, most of the time when
No, it's not.
No, it's not. Okay. The second question is that you already said that there is kind of uplifting conditions in the Sumatra, because maybe that is because of the tectonic displacement of the tectonic in the Sumatra. But my question is, based on your view, like even in the whether there is no mangrove or not, the land is truly sinking because of the massive construction and buildings in the top sediment. So based on your view, like, do you have any kind of suggestions? Do we have to move all of the people and facilitations from those areas into kind of other areas, such as like Jakarta to IKN, or do you have any, based on your personal view? Thank you.
You're very welcome. First, let me talk a bit about the data availability. Unfortunately, the data was not necessarily public, but I think throughout in the last, I think, 5 years, the Indonesian Geospatial Agency or BIG, Badan Informasi Geospatial, has thoroughly changed in a sense that they are aware that they cannot do it themselves. So they started to share the data publicly, although with asterisk. I need to say that with terms and conditions. And the best thing that I so to say suggested to anyone who wanted to use the data is simply contact info@pig.go.id and go from there. They will try to help you as much as they can, as long as I remember. That would be my first answer. The second one, it is actually will get a bit political if I'm being honest with you, because I'm not in a sense agree with the decision of moving Jakarta to IKN. Why? Because as shown in my research, although again, granted, and this is the limitation of my research, I need to do a further investigation, but I found that the rate of subsidence has been slowed or lowered compared to the last 10 years, meaning that whatever effort that was done by the government, whoever the government was or is, it works somehow. Meaning that if you ask me, do you think that I suggested to the stakeholders to move people? I mean, like in Bahasa Indonesia, we call it patrol desa. I don't really know the English word to other location wholeheartedly. I don't really think that would be a best idea, and it is a radical idea. Some people are suggesting that, but I don't agree with that. What I do think could be done is, as I mentioned on the last slide, we need to work with the communities, and also we need to also work on the policy side. But first, I think we also need to understand what is the main factor behind the rise or the subsidence. In Jakarta case, it was the groundwater extraction, as all of you probably has known. In Bangladesh, it was different because it was made on the delta, and the delta is sinking nonetheless, and that is a different problem actually. And I think San Andreas fault in America, in the United States of America, it also has a different reason. I mean, the reason were essentially the same, but then when we're not talking about the symptom, but we are talking about the cause, it might be different. So I do think the radical that you have mentioned is not necessarily the best one. And I think the best one would be to work with the communities to raise awareness, like what we are doing now, and also try to change by the system. So that would be my answer. Hopefully it answers your inquiry.
Yeah, he said that it all answered the question. Thank you very much. And then the last question? No? Okay. That's basically end our session. Thank you very much once again, Zulfikar, for your presentation.
You're very welcome.
Yeah, before we closing this session, the committee would like to take a picture for us and with all of the speakers. So please kindly open your camera again. We would like to take a documentation for this session. And for the speakers who are here, please go forward and then, yeah, let's take a picture. To everyone in the Zoom meeting room, please kindly open your camera for the documentation session. Thank you. So thank you very much, everyone. And yeah. So yeah, we have now reached the end of this session, and it was indeed very insightful session, and I was actually very impressed with the wide variety of idea that presented. Hopefully this idea can be developed and also follow up in the near future. I would like also say thank you to all of the speakers today for the great presentation, and also for everyone who attending this session. It was a pleasure to have you with us, and hope you are enjoying this session. And I will go back to the MC, Mas Pinju. Thank you very much.
So thank you so much for Ms. Satifa to moderate our conference here. And yeah, for your information as well, we actually now having the plenary session in the ZHG 10 room. So if we can also having time, we can also go there to have the plenary session. And the theme of the reducing AVLU emission, balancing development and conservation. So yeah, thank you and see you in another occasion. Thank you. Thank you, guys. Thank you, thank you. Thank you, thank you. Besok lagi masih ada.